Hello guys, today I'm going to discuss on the topic of compiler optimization. If you find yourself having difficulty debugging your firmware, the reason could be compiler optimization. Let us take for example the code here. We have a result variable and it is assigned with a random value. And let me step debug into this code. We're now in line 78. We have a breakpoint variable expression on top, but the result variable is marked as identifier not found. Let me step debug into the code. Let me assign a random value to the result variable. Still, it is marked as result not found in the expressions window. The reason for this is compiler optimization. The result variable is, in this example code, never used anywhere else. So the compiler optimized the final machine code and deleted the variable as if it did not exist. Suppose we are going to use the result variable down below. So let me uncomment this section here. We now use the result variable and we do a check if it's greater than 100 and then we break out from the loop. Let us now step debug into this modified code and let us observe how the compiler optimization reacts to these changes. Right? We are now step debugging into our code, and in the expression list, we now have result marked as 0. Okay, let us step into the execution of the code, and it's been set to 5839, and it's been set to 14870. So you'll notice that the value of the result variable is changing every time I step into the code, which is very unusual. The reason for this again is compiler optimization. Let me explain. The value that gets assigned in line 79 is a don't care assignment. Doesn't matter because in the loop here, it is going to get reassigned with another value. And that was the reason that the value was fluctuating to a don't care or random garbage. The debug session is not holding to this value because it's irrelevant. It's going to be reassigned anyway with a new value in line 118. Let us turn off compiler optimization to prove this hypothesis. Right click, and right now it's set to 2, to a level of 2 optimization. Let us turn it off, apply and close, and let us debug it again. We just turn off compiler optimization and let us step debug into the code. We can see the result variable in the expressions window as having a value of 0. Let me step debug. Let me step debug to line 79 now. And it acquired a random value of 20,690. Let me step debug more. And you can see that that value has stabilized. It's being kept simply because there was no compiler optimization. Let us stop debugging now. Let us enable compiler optimization again to 2 and step debug into the code. And we are back to the situation where the value of result is fluctuating simply because the IDE, the debug window, knows that it doesn't matter. It's going to be reassigned anyway below. As a second proof of that, let us move this result statement below here and let's delete this one here. In this arrangement, now that this line has moved under this F check where result is used, the value that gets assigned in line 79 will now matter. It will not fluctuate simply because the assignment is moved below and this check here is going to be an important statement now. So let us prove this scenario. Debug again. We enter into the step debug window. Result is set to -1. We're now at line 79. The result is assigned to 8,278. Let's step one more time. And you can see that the value result is being held and stabilized and it's no longer fluctuating simply because the compiler knew that that is going to be very important and it's going to track that value in the debug window. It's not optimizing it, and this is the reason. And I hope that I've showed you that an optimizing compiler is going to rearrange the final machine instruction as it gets compiled, which means that the appearance of the code in the editor may not be what it seems as what is in the actual compiled code due to compiler optimizing certain things and making conclusions at compilation time that certain variables um, have a predictable value. So when you debug it, you can see those values fluctuating in the watch list because it doesn't matter. The value is going to change anyway. Your debug session is going to get confusing if you don't understand this topic of compiler optimization. Of course, you can always choose to turn off compiler optimization in the settings. And if you do that, then the variables will always, things are going to behave as expected simply because there was no optimization being done and the appearance of the code in the IDE will closely resemble that of the machine code executing on the hardware. Thank you, and this is all for now.